two polar functions, and we're supposed to find the area between them. So if you take a look at the graph and you just look at the two of them, let's see, I'm not really sure which one is which, but since we're the area inside one and outside another, I would imagine that's this area in here. So to make sure, I can take one of them off for a moment. So this is the big one, so it's supposed to be inside the big one and outside the small one. Now, the next thing we need to do is regraph it and watch and make sure that 0 to 2 pi is not too much for the interval for theta. So if you regraph it and watch, mine's drawn them both at once. Now what just happened is 0 to 2 pi drew the outside one once and it drew the inside one twice. So 0 to 2 pi is not going to work for this little guy. So what we got to do is say, how about if, as a guess, I'm thinking maybe 0 to pi. And then have go and notice it stopped as soon as it was done with pi. So for the little one, we need to use this one. We need to use 0 to pi, and this one we need to use theta goes from 0 to 2 pi. Alright, now the idea is to find the area between them, and because one is completely inside the other one, what we do is just take the area of the big one, subtract the area of the small one. So we're going to have, another way you can tell which function is which is just put trace and then it'll tell you the big one is this guy. So we'll have integrate 1/2 r squared from 0 to 2 pi for the big one, and then r for the big one is 2 plus sine of theta. And then subtract from that the area that you get from the small one, 1/2 3 sine of theta is squared. So for this one, factor out the 1/2 and go ahead and multiply this out. So we're going to get 1/2 and then integrate from 0 to 2 pi. It's going to be 4 plus 4 sine of theta plus sine squared. And then for this one, again, you could factor out the 1/2, and it's going to be integrate 9 sine squared and even though this one has sine squared and this one has sine squared, in this case we are not allowed to combine them because this one's going from 0 to 2 pi and this one's going from 0 to pi. So we'll just have to do them separately. And here's where we need to use the formula sine squared is equal to 1 minus cosine of 2 theta divided by 2 to replace the sine squared. So I'm going to go ahead and do that right now, and I'll do the integrating afterwards. So 4 sine of theta, and then 1 minus cosine of 2 theta over 2. I'm going to factor out this 9, so there's 9 halves, and then integrate from 0 to pi 1 minus cosine of 2 theta over 2. Alright, now integrate. So 1/2, this is going to be 4 theta plus, actually this is going to need to be minus negative 4 cosine of theta. Then I'm going to break this into two fractions. There's going to be the 1/2 and then there's going to be the negative cosine over 2. So for the 1/2, that's going to be plus 1/2 theta, and then we would have minus sine of 2 theta over 4. So it's already over 2. You would then need to do the chain rule, take the derivative of this, and then divide by that 2, which now creates a 4 here. And then evaluate that from 0 to 2 pi. Minus 9/2, and then this is going to be a 1/2 theta, and then minus sine of 2 theta over 4. This one evaluated from 0 to pi. All right, now substitute 2 theta. So let's see, this is going to be 8 theta. This is going to be cosine of 2 pi. Well, cosine at the end of one cycle is at 1, so this is going to be a 1 times the negative 4. Then 1/2 of the 2 theta, so that's going to just be theta. Excuse me, pi. This is supposed to be pi, not theta. We replaced it. Okay, so this is 1/2 of 2 pi. The 2's will cancel and it just leaves pi. And then sine of 4 pi is equal to 0. And then that one, I still need to substitute 0. I was thinking that all of these are going to be 0, because this would be sine of 0, this would be 0, and this would be 0, but cosine of 0 is 1, so there's actually minus a negative 4. Excuse me for this. Okay, so then when we substituted the 0, so you do the first one, blah, then minus, and now substitute 0. So this is 0, cosine of 0 is 1, so this is negative 4, and then this is 0, and this is 0. Oh wow, the 4's are going to cancel. All right, next we've got minus 9/2, and this 1/2 when we integrate it is 1/2 theta. So put theta right here, and there's going to be pi cut in half. And then this is going to be sine of 2 pi, so that's 0. Next, substitute the 0. This is gone. This is sine of 0, so that's gone. So let's see. Like I said, the 4's can cancel. This is now 9 pi over 2. And then minus, this is 9 pi over 4. So if you get a common denominator, or actually if you just look at it this way, you've got, think of this as 1/2 minus 1/4 is going to be 1/4, except it's not 1, it's 9 pi quarters.